color of my blood. You're the cure.
Circles and chords and other lines that go through the circles. What relationships do they have? So on 34 here, we are going to draw some circles and tangents and see how the tangents and the chords relate to the circles. So consider all the ways that a circle and a line can intersect. Can you visualize a line and a circle that intersect at exactly one point? What about a line that intersects a circle twice? On your paper, draw a diagram for each of the situations below if possible. If it is not possible, explain why. Okay, so for the first one, draw a line and a circle that do not intersect. And this does not have to be perfect, so let's just put 10-34. Draw a line and circle. Can a line not intersect a circle? Yeah, you just draw them separately, right? There you go. 0 intersections. Okay. How about, can it intersect once? How can it intersect once? So make a tangent. So we make the line barely intersect the circle at one point. So that's one intersection. One intersection. Okay. C says draw a line and a circle that intersect at exactly 2 points. Okay. So can a circle and a line intersect exactly at 2 points? Yeah. Yes. The line just goes through the circle, right? So once, twice, 2 intersections. How about 3 times?
No.
Okay, so if it's not 2 times, the only way 3 times could occur is if, you know, the line came back and went like that. But we're not counting those types of lines, right? So it's just going to be, no, not possible if we just have a straight line. And then we're moving on to 35. So 35 says, zoom in here, says a line that intersects a circle exactly once is called a tangent. What is the relationship of a tangent to a circle? Okay, so let's draw this circle with our compass if possible. So 10-35.
I'll borrow a compass.
Yes, you may. So make our circle here. So we draw a tangent to the circle, and in our book it looks like that, so let's draw it kind of like that. And that point that it's tangent to it, let's call that point P. This is circle A, and let's draw a radius to that circle. So, this is out of the way. So I'm going to darken it a little bit so you can kind of see the circle that I drew. Does it look like there's some kind of relationship with the radius and this is what we call a tangent? It's a perpendicular, yeah, they're going to be perpendicular lines. So whenever you draw a tangent to a radii of a circle, they're going to be perpendicular. Like I can make another radius over here, right? And if I draw the tangent to the circle at that point, I'm going to make it 90 degrees. Oh, I could use my ruler to line up the lines and make it 90 degrees like that. That's going to be, so this tangent line, that's what we call a tangent line, is always going to be 90 degrees perpendicular to the radius. Okay? And actually, if I connected these, those would actually be, these would actually be equal too. So, all right.
So this is the thing where it's like on like standard test where it's like if lines are tangent.
Yeah, if lines are tangent, that's why it says that on the standards quiz, exactly. Okay, and that's all we really need to get from 35. 10-36, and unfortunately I don't think there's a lot of tangent lines when it says that on the standards quiz, but some of them are. So 10-36 looks like this. So let's draw the circle with a tangent line and then one radii to it and then these other lines. And it says to make PE equal to EA right here. So let's use our compass to do that, okay? So let's make our circle again. Doesn't have to be very big. I guess it's kind of a medium-ish circle. And then I'll draw my radius straight up to the top of the circle, and then make a nice 90-degree angle right there. Okay, and then so if I want equally distant points, I'm just going to use my compass to make sure they're equally distant. So I'll make a point on this side, and then I'll flip it around to the other side to make sure it's the same amount of distance away from. So I'll just put my compass there, put it there and there, and that will be where I make my triangle. So to make sure that they're congruent. Okay. Okay. So let's prove that these triangles are congruent. This is triangle P, E, A, and then R, pair. How can we prove that they're congruent? Are there any congruent angles? Yeah, the right angles are congruent, right? So angle PER, so let's put angle PER is congruent to angle AER, because all right angles are congruent. That is a reason you can use on your proofs. All right angles are congruent. Okay, so we know one angle. We have an angle. We need more. So we have a reflexive property going on here, right? They share a side, so that's a side. ER is congruent to ER, reflexive property. Sure, if you like. So we have a side, we have an angle, we need one more piece, either a side or an angle. And because we constructed, remember when we did our construction to make sure that these were equal, it was kind of our given, because it said it, like those had to be equal. It said make PE equal to EA, right? So that's our last side right there. Side PE has to be congruent to AE. So what does that give us? What side, angle, side, right? So the two triangles are congruent by side, angle, side. So triangle PER is congruent to triangle PER is congruent to AER by side, angle, side. Yeah, so we did like a little mini proof there. That finishes up 36. Okay, for 37, I don't want to make this so long, but 37 has these 6 problems, okay? For this first problem, let's go ahead and draw it and then label the sides that we have here and see what we have going on in this triangle. Okay, so if you draw it, it's going to look like. Just take my paper. So circle, tangent, radius, that is x, and then we have this point Q over here, point C, P, and then they tell us this is 5, and they tell us that from here to here is 6, and they want us to find CP. Okay, so x is equal to what? And actually they want us to find angle C as well, this angle also. Yeah, please sketch that. I want to sketch it. Okay, so what kind of triangle do we have going on here? You know it's a right triangle? Yes, because we have a radius and this side tangent, so that has to be a right angle. Okay. Don't need it right now. Okay, so we have right triangle. So what can we use in this right triangle to solve for x? Pythagorean theorem, right? So x squared this side, plus 5 squared equals 6 squared. So let's square the 5. X squared plus 25 equals 6 squared. 36. We're going to subtract the 25 from both sides. X squared equals 11. And then you take the square root. So x equals the square root of 11. Okay, if you want to change that to 3 point something, then you can change it to whatever 3 point it is. But exact value answers are better. Okay, so now we want to find this angle C. We know this side is 5, we know this side is 6. What can we use to find angle C there? Sine? Okay, so we're going to take the sine of the opposite side is 5. Sine of, we don't know, C is equal to 5 over 6. Okay, that's how you set it up. So sine of C, sine of the angle, C is the angle we don't know, equals 5 over 6. So you're right. Since we're looking for the angle, C is going to be the inverse sine of 5 over 6. Okay, so get our calculator. Second sine, 5 divided by 6 gives us 56.44-ish if we round. Okay, so C is approximately 56.44 degrees. And that's that angle right there. Alright, so that problem done. Let's look at B. B. So let's draw this circle for B, where we have circle H. One of the angles is 40 degrees, one of the arcs is 210 degrees, and then we want to find these measures. Okay, so I don't think it needs to be super accurate. We could just draw it by hand. And we do want a diameter going through there, though. And diameter GO, and then GR is a chord. And GD is another chord, and H is the name of the circle. Okay, and it tells us that this arc right here is 40 degrees. And I'm going to send you out. That's 40 degrees. And what else does it tell us? It tells us one of these arcs is 210 degrees from G to R is 210 degrees. Yeah, so, yeah, from G to R. Right? Oh, is it the other way? You're right. Maybe it's the other way. Oh, it can't be the other way. That's right, because it's more than 180, so it has to be. That's why I figured out it was that way. Okay, so, oh yeah, it says G-O-R. Sorry, I read it wrong. G-O-R. And so we want to find the measure of OR, measure of arc OR. And, oh, I forgot GD, the measure of arc GD as well. And the measure of angle RGO. Okay, so GD, let's get some color coding going here. GD is this arc, we want to find that. And then we want to find OR, which is this arc right here. And then RGO is this angle right here. That angle, which kind of goes with this arc right here, right? It corresponds to that arc. It's not equal to that arc, but it corresponds to that arc. Okay, so let's see. How can we find this angle right here? We know this is 210, right? And we know 180, a semicircle is 180. So 210 minus that 180 will give you that little section there, right? So 210 minus 180 is 30 degrees, right? Maybe some of you thought it was going to end up being the same as this because they kind of look the same, but not drawn to scale. So OR is 30 degrees. Okay, so we know this is 40, we know this is 210. How can we find this green arc here? Add them all up, right? So 210 plus 40, 210 plus 40 equals 250. The whole thing, the whole circle has to be 360 minus 250. So this should be 110 degrees, right? So all that added up equals 360. So 110 degrees. And then last but not least, RGO is this angle right here. And is it 30? 15. It's half of 30, right? So it's 15 degrees. Because it's an inscribed angle. It's coming from the side. It's not coming from the center. Okay? Inscribed angle. Okay. Yeah, well, on your own, you mean?
No, because when we do them on our own, then you have to leave like a weird space on your paper. I think that also these like things that go into like F or E have like all the possibilities you can encounter.
Yeah, not really. Some of these are from like this is like yesterday's, right? This is a review from yesterday. This is a little challenging. This is
Just not here the other day, so we should do them all together.
Do we have to draw?
no. Yes, please draw the circles. Just do a little sketch, okay? Okay, so I am going to let you do the rest. So leave a space for C, D, E, and F, okay? You're going to have to leave more space than I'm leaving, but you're going to leave that space. Okay, then we're going to move to, now believe it or not, chapter 11 is on the back side of this. Flip it over and there's 11, and we only have part of it. Look at that. So we transferred from chapter 10 to chapter 11. Oh yeah, oh, okay, forget. So turn your books to 1122. Okay? Turn them over. Yes. It has the Earth on it. It has some satellites on it. We're going to use it for this problem. Okay, so you want to have this paper for number 80 here. Okay. So we're going to read it together, and this is the one you got to pay special close attention to, okay? It's not an easy problem, and it's lengthy, and we're going to go into detail here. So, did you know that as of 1997, over 8,000 operating satellites orbited the Earth, performing various functions such as taking photographs of our planet? One way scientists learn more about the Earth is to carefully examine photographs that are taken by orbiting satellites. It's also a good way for us to spy on other nations. However, how much of the Earth can a satellite see? What does this depend on? In other words, what information would you need to know in order to figure out how much of the planet is in view of a satellite in space? Discuss this with your team and be ready to share your ideas. So, on your resource page, let's draw an angle from satellite A that shows the portion of the Earth equator that is visible from the satellite. What is the relationship of the sides of the angle and the circle that represent the equator of the Earth? Okay, so what we need to do is take our paper and take a straight edge, definitely do this with the straight edge, and draw a tangent line, be very careful with how you do this, to the side of Earth. Draw a tangent line to the side of Earth. And it should intersect right around, here, right? Right around there.
Where's like the point that we should place my mark?
Like the middle of the satellite, right here. Yeah, the circle part of the satellite. Okay, and then draw another tangent line to the other part of the Earth so we can see its line of vision. So, like right here. Okay, so those are our two tangent lines. This is our tangent 1, our tangent 2. It looks like a 90-degree angle, you think? Well, we're going to have to find that. So, part B says, draw a quadrilateral ADEF that connects satellite A, the points of tangency, and the center of the Earth. If the measure of satellite A is 90 degrees, what is the measure of the equator's arc that is in view? Explain how you know. So if we know this is 90 degrees, they're telling us, yes, indeed, this is 90 degrees. Can we find this arc right here? Okay, and I'm going to highlight it yellow. And they said to make a quadrilateral. Okay, so I want to find that arc there. It actually goes to there. Okay, so I want to make a quadrilateral, and it's with the center of the Earth. So let's draw from the point of tangent to the center of Earth, or the top of the Earth, I should say. Like that. Okay, that's 90. And don't we know these angles right here? This is a tangent and a radius. So those are 90 degrees as well, 90, 90. So this has to be 90, but that's 90. If that's 90, what is this angle measure here? This has to be 92. This arc has to be 90 degrees. Okay, so we found that arc. What is the arc of this remaining, the other side of the Earth that can't be seen? So there's 270 degrees, right, that can't be seen by satellite A. And I'll put it in yellow. Okay, now we want to do it from satellite B and see how much, if we send the satellite further out, higher up, can we see more of the Earth or less of the Earth? Okay, let's see. So let's draw a tangent line here. So they're supposed to stop. And then go to the other side here. You guys say we can see more of the Earth. Okay. And let's draw to the center, the radius to the center now. And basically, it increases one of those like longitude lines, huh? Those longitude lines? We're looking top down? Yes. Yes. There. So this is a right angle. That's a right angle. So now we want to find this arc, this new arc that goes from here to here to see how much of the Earth we can see, and we want to find, well, they're going to tell us this angle. Zoom out too close there. Okay, and I think they tell us the angle is 60 degrees. They tell us that in 82. Yeah, in part B, so this is like 1182. Part B. They tell us that this is 60 degrees, and they want us to find this arc. Okay. Well, if this is 60, what kind of quadrilateral is this that we're drawing? It's a kite, right? So I'm going to make it green too, and it green, this radius green. It's a kite. Well, if this is 60, this is 90, this is 90, so in my kite, you know, I have a kite like this. Actually, it's longer and then shorter. So it's 60 degrees here. Actually, that's supposed to be 90. How many degrees does a kite add up to? 360. Well, 180 of it is taken up by these two, right? So half of it is taken up by those two angles. So these two have to add up to 180. So this has to be 120. So this angle right here is 120 degrees. I'm going to draw over whatever country that is. I don't know, is that Iceland or Russia or something? Oh, I don't know. Russia? It's kind of backwards, huh? Well, Russia's like more over here, right? It's backwards. Okay. Sweden. Okay. So if that's 120 degrees, what is the visibility range of the satellite over here? No, it's from the central angle. It's 120, right? So satellite B has a visibility of 120 degrees. Okay. And that inside angle is 60. Alright, so now let's try satellite C. Let's go for satellite C. I'm going to make that one red. I think I have red around here somewhere. Yeah, I think so. Satellites are pretty interesting. So, satellite C is going to go from there to there. Are we going to be able to see more of the Earth from satellite C? If it's higher, further away?
No, man. Maybe.
So actually, it goes to the next longitude line, right? Actually goes to the next longitude line. So yes, we are able to see more of the Earth. That's 90 degrees, so zoom out now. Okay, and I don't know if they tell us this measure here. Oh yeah, they tell us it's 45 degrees. If this is 45 degrees, then now we have our very narrow skinny kite that has a 45 degree angle here and a 90 degree angle and a 98 degree angle, even though I didn't draw it very to scale. It should be more like this. Like that. So, how can we find that angle right there? Okay, 180 minus 45, right? Why is it 45 degrees? Okay. So, 180 minus 45 gives us 135 degrees. So this angle in here, from here to here, red to red side, is 135 degrees. So if that's 135, then this arc from this part of the world to this part of the world is 135 degrees. So yeah, we can see more the further that we go out, right? What's the relationship between this angle and that arc? They're always going to add up to 180, right? Yeah. So anytime you have like two tangents and a radius going to it, then that angle is going to be supplementary to the arc that it intersects. So this 60 goes with 120, this 90 goes with another 90. It's always going to be supplementary, okay? And then we have to write that down like somewhere for 82. We could write it on, actually that's 83. So let's say the angle from the satellite is supplementary to the arc that it intersects, right? They're always going to add up to 180. That 135 plus 45 makes 180. Okay. Let's take a look at this worksheet, because part of it, what if, that's if they tell you this. What if they don't tell you this? And so this is like a satellite problem, but again, these aren't tangents either. So what if they're not tangents and they're going through the circle and we want to find them, okay? So everybody has this worksheet, yes? Okay. So we actually have three kind of different but similar situations here, yeah? No? Okay. So before I get to that one, these situations, these lines, this one intersects on the circle, okay? So this one represents on the circle. What do you do when the lines intersect on the circle? This is what you do. We know that this arc is 234. We can pretty easily figure out this arc, right? So what's the relationship between this and that, this angle and this arc going to be? Is it going to be equal?
Yes. It's going to be half of the other.
Let me get my pencil to write on. Okay, so what if I straightened out this line a little bit and I went like this? Okay, I changed this line and went like this and made this angle go over here. Now, if I'm assuming this is a diameter, how many degrees would this be? That would be 180. Is this 180 degrees? Not even close. It is. It's 90 degrees. So the relationship between the angle and the arc is going to be half of it, okay? So whatever that arc is, you're going to take half of it. If it's on the circle, it's because it's on the circle. Okay, so easy enough to take the 360 minus the 234 to get 126. So this arc right here is 126 degrees. I can erase the stuff that originally wasn't there. So that arc is 1 in 26, so we divide that by 2, right? And get 63 degrees. So angle 1, that angle right there should be 63 degrees. Okay. We took 360. We've minus 234 from it to find this 126. We divided that by 2 to get 63. Done. Okay. Now, if the two lines, these two lines are not intersecting on the circle, right? These two lines are intersecting inside the circle. So when they intersect inside the circle, you need to add and divide by 2. Okay. So what do we add? I'm adding this arc and this arc, because those are the arcs intercepted by the line, and those are the ones that we know. So I'm going to take 102 plus 194 and divide by 2, and that gives you the angle measure, angle 1. Okay, so 102 plus 194 divided by 2, 102 plus 194 is these two together make 296 divided by 2. 148 degrees equals angle 1. So this is 148 degrees. Okay. So it can be on the circle. The two lines can intersect on the circle. Then it would be half of the measure. It could be in the circle. Then you add and take half the measure. Or the two lines could be coming from outside the circle. They intersect outside the circle right here. Like if I were to continue this, they would intersect outside the circle. When they intersect outside the circle, which is kind of like the Earth problem, right? One of the things we could have done on the Earth problem is, and one of the things we actually did do, is we took this arc and you subtract and divide by 2. So when it's outside the circle, you subtract and divide by 2. So those are the three possibilities that you can have. And which ones do you subtract? Well, you take the bigger one and you subtract the smaller one. We don't want a negative number, right? The bigger one's always going to be like furthest away from the satellite. So 104 minus 38 divided by 2 is going to give me the measure of angle 1, which is...
That's why you wanted mine.
So 66 divided by 2 is 33 degrees. So angle 1 is 33 degrees. All three of these types of problems are on your standards quiz. Okay? And each week it varies. It could be this one this week, it could be this one next week, it could be this one the following week. It's a hodgepodge. So you have to know how to do all three of them. On the circle, in the circle, outside the circle.
What do you do for on the circle again? What's the...
You take 360, you minus the 234, you get this side, and you take half of, this is going to be half of this, and this is going to be half of this.
So is it subtract and divide by 2?
Sure. It's just divide by 2. You have to find, it's just whatever arc it is divided by 2.
Oh.
Okay. So all the other ones, pretty similar, same deal. So you have the rest to do for that. Yes. This one, this is a two-step problem, number 4 here. Let's say you want to find angle 1, which is this angle, but that involves this arc and this arc, right? So I don't know if you can see that. So this arc minus that arc. Okay, we don't know this arc though. So what we want to do is use this method first. Since we know this is 93, can we add these two together and divide by 2 to find what this is? Okay, so I'm going to call this like x for right now because we kind of need it and it's not labeled x. Okay, so 142 plus x, 142 plus x divided by 2 equals 93. So you add this one, plus we don't know this one, but we do know this one. So 142 plus x divided by 2 equals 93. We can solve this for x. What do we do first to solve for x? Multiply by 2. Multiply the 93 times 2. 2 is 186. So we get x plus 142 equals 186. Subtract 142. So x is 44 degrees. So this arc measure right here is 44 degrees. So now what do I do with these arcs? You subtract them. It's like this. So we take the 142 minus 44 and divide by 2. Always divide by 2 on all of these, right? You're dividing by 2 somewhere in the problem. That equals angle 1. 142 minus 44 is 98 divided by 2 is 49. So angle 1 equals 49 degrees. Okay?
Alright.
So that was a two-stepper. So, I don't know. And then this was kind of like what we did the space problem, so it's pretty easy. All right.